Hi everybody, this is Mrs. Dinkelman, and these are the notes for 6.4. It's the second half where we're going to talk about the fundamental theorem of calculus. The fundamental theorem of calculus actually has two parts, and this is just one of the parts that we're going to apply on this assignment, and then we'll talk about the second part. And the reason it's so fundamental is it ties this idea of the derivative and the integral kind of together. So that's why they call it the fundamental theorem of calculus. There's actually a fundamental theorem of pretty much every math subject that there is. The fundamental theorem of algebra is the one that tells us that there's the same number of roots as there is a degree in a polynomial, just kind of FYI. Okay, so Gary kind of wants us to go through to see that this fundamental theorem actually does work rather than just saying this is what it is. So on A it says we're doing the integral from 0 to 5 under this f prime. And now that we know that this just means area, we're looking for the area under this curve. I know it's a line, but he did that on purpose because that makes it easier. Okay, so that's just a base times height, and so it's 15. Okay, so it says write an equation for f prime from there to there. So f prime is really just 3. Technically, not plus c. Okay, I haven't taken the antiderivative. That letter C, I'm going to take the antiderivative. So we're going to do a little bit of work here. We're going to actually figure out what the antiderivative is, and then they gave us information to figure out what C is going to be. So it looks like C equals 1. So I'm just going to go ahead because I'm running out of space and just put a 1 there. Okay, so now they want us to figure out what f of 5 minus f of 0 is. And so let's see, f of 5 is going to be 16, and then f of 0 is going to be 1, and so our result is 15. And what he wants you to notice then is that finding the area under the curve, we could do it by geometry like in part A, or we could just find the antiderivative and plug some things in, the 5 and the 0 that we're looking for, and find that same area. So that was with a horizontal line. What if it's a slanted line? Okay. So let's see, on A here from -2, so we have to be careful here. We're always finding the area between the function and the x-axis when we're finding area here. So that first bit of area is actually going to be negative. So that is a 1 by 2 triangle. So 1 by 2 divided by 2 would be 1, but it is below the axis, so we know it's negative. We also know that because the height of it is technically negative. This next one is a 2 by 1, 2, 3, 4, 2 by 4, so 8 divided by 2, which is 4. And so I think our signed area for this particular thing is 3. Okay, let's find the equation of this line for f prime. So f prime is actually, let's see, the slope looks like it's up 2 over 1, and it crosses the axis at 2. And that'll help us then find f of x. So let's see, that's going to be x squared plus 2x plus c. F of 1 is 0. So 1 plus 2 plus c has to be 0. So c must be -3. Again, I'm just going to come up here and erase and say -3. Okay, so let's figure out what f of 1 minus f of -2 is. And if it's like last time, we think we're going to get 3, but let's just see. Okay, so if I plug in 1 in, I'm going to get 1 plus 2, which is 3, minus 3, which is 0. And if I plug in a -2, I'm going to kind of keep track of this because I'm afraid that I'm going to mess that up. Okay, yes, we get +3 again. So this first fundamental theorem is really just telling us that rather than trying to find the area geometrically, we can just find the antiderivative or integral of that particular thing and plug our numbers in and figure out what the area is. Okay. Really quick on 9, kind of talking about displacement and position. So remember with displacement, what we're going to do is find x of 4 minus x of 1. And let's see what that's going to be. So I might have to keep track a little bit here. So 4 squared is 16 and times -1/2. and then plus 16 minus 3. And if I plug a 1 in, unfortunately, there's our fraction. And let's figure out what this equals. So in this first chunk, 8 minus 3 is 5. And in this one, we get, so we have 1 minus a half, which is a half. So I believe we're going to get 4.5, or 9/2 for that. Okay, let's go ahead and find the velocity. So we have to take the derivative to find the velocity. So the 2 pops down and cancels, but there is still a negative t plus 4. It wants us to sketch the graph of that. So luckily I didn't use up too much. We're going to go ahead and go down 1 over 1, or let's just figure out where it crosses the x-axis. So that's going to be at 4. I guess it's technically the t-axis. Forgive me for not having very straight handwriting on this screen. And then on D, it just wants us to find the area from 1 to 4. So that triangle right there. So let's see. So from 1 to 4, the base is going to be 3. The height at 1 is going to be 3 divided by 2. Guess what? 9/2. Okay, so again, notice, like he said, that the answers to A and D are the same. So here's really what we get to do for the fundamental theorem of calculus. Here's the math part. So if we're trying to find the area under the curve, or if we're trying to calculate an integral, what we get to do is we get to take the antiderivative. This is kind of good notation for saying what we're going to plug in. And again, what we're going to do is plug in the upper limit first and then the lower limit, and we subtract those two things. Okay, so let's go ahead. We're going to skip number 11 because it has a 4 on the inside, and we're going to talk about use substitution later. You can tell that we've skipped 6(3). We're going to come back to that one, and we need that one for number 11. All right, I'm just going to rewrite number 10 as 2y to the 1/2 plus 1, so we can find the antiderivative. So I'm going to add 1 to the exponent, technically divide by the new exponent. I've said it a million times, I don't like that. I'd rather have this be a 2/3 right here, plus y. We actually don't have to find the plus c to be able to plug these in, because if I add 5 and then subtract 5, or add 4 and then subtract 4, those are going to go away anyhow. Okay, so I'm just going to use this notation that lets the grader know that I still know that I'm supposed to go from 0 to 4. And then the procedure here is we're going to plug in the 4, and then we're going to subtract, and we're going to plug in the 0. So really quick, I just want you to know that my brain thinks of this as 4/3 y to the 3/2. Okay, so it's going to be 4/3 4 to the 3/2 plus 4. And now I'm going to plug in the 0, which is actually really nice because I like to see zeros. It means this whole side is basically just going to be 0. Okay, 4 to the 3/2. I'm going to do the 1/2 first. So that's going to be 2. 2 cubed is 8. So this is going to be 32/3 plus 4. So I'm going to think of it as 32/3 plus 12/3, which is 44/3. Okay. It will let me. Gosh, we're going to skip 12 because that one's going to take use substitution as well. And let's just do, we'll do this one, but we'll pretend like it just says cosine x, because we're going to do those kind of problems a little bit later. Okay, so on this one, again, we're going to take the antiderivative, which is sine. Take a quick pause for a second, make sure derivative of sine is cosine and that you don't need to add a negative or anything like that. Again, indicate that you still know that we're going from 0 to pi over 2. We plug in the upper first and then the lower. So sine of pi over 2 is 1. Sine of 0 is 0, so this one is just 1. Okay, so let me make sure there's not any others there. I didn't think there were. Oh, yes. So sometimes we have problems where they give us a little bit of a start. We started at a particular location. I think we talked about this with our Riemann sums a little bit. But if we basically get a head start, when we find our integral or find our antiderivative, we have to kind of include this fact in there. So We're going to skip 15 just because it has that 2 to the something, by the way. But on this one, we can figure out, find f of 2. So what I'm really going to do is I'm going to use my head start. And my head start started at 0, which is normal, but it could really start anywhere. And I want to find what f of 2 is. So I'm going to go ahead and just put the 2 up there because that's where I want to stop taking my antiderivative. Okay, so again, think of this as a head start. We started at 0. We're going to end at 2 and see where we're at. Okay, so our antiderivative here, and maybe we're getting a little bit better to see, that's just going to be an x cubed plus 3x, and we're going to evaluate at least this part from 0 to 2. So let's go ahead and plug in the 2. So 8 plus 6, plug in the 0. Really nice to have zeros. And so we're going to have 18 as where we ended up. So basically what I can see here is that I'm kind of almost thinking about a race. You can tell is thinking about the head start thing. So with the integral, we found out that we went like 14 spaces, but we already knew we were at 4. So the integral just tells us how far we traveled. Okay, that should be it. You should be able to finish 6.4 now. Do make sure that you looked at the homework assignment and know that there are a few that we're going to skip in there.